welcome to Staad tutorials. In this session, we'll be dealing with the RCC building subjected to different types of slab loads as shown in the figure, up to 7 stories. So as you can see, the building is of 7 spans. On one side it is 3.5 meters each, and on the other side they are divided into 3 type spans. So initially we'll draw from here to here, then from here to here, and we'll combine the both. So let us begin. Start Pro. Select new project, select space, give name, give units as meter and kilonewton, select next, select add beam, finish. So now you go to geometry, select run structural wizard, and as per the figure, it is 7 spans of 3.5 meter each, long lengthwise, and widthwise there are 2 spans 4.5 meters and 1.5 meter. So we select frame models, pay frame, give length as 24.5 meters, number of spans will be 7, and height will be 3 meters, number of spans will be 1 meter, width will be 6 meters, number of spans will be 2 meter. Select widthwise the spans, select 4.5 and 1.5, select apply. So you can see this is our model. We need to transfer this to main Staad Pro screen. Okay, so you can view it in 3D view. You can see as per our figure there isn't a beam here, so we need to take out this beam. Select this beam and select delete button. Then you can also see that there aren't columns here, this 3 and here 3 and here and here. So you need to remove those columns. So you select those particular columns. And select delete. You can see that there are columns here but they are not here, so this need to be removed, these columns, both of them. Well, we are done with one part of the building. Now we need to do the other part, which is of 7 spans and 4.5 meter width. So select geometry, select run structural wizard, select frame models, bay frame, length will be 24.5 and number of spans will be 7, and the span lengths will be first 2 or 3.5, next is 4 meters, and next is 2.5 meters. meters, 2.5 meters, 4 meters. Okay, height will be 3 meters, width will be 4.5 meters. Span is 1. Select apply. Now you have created your model. You need to shift this and apply to your main start pro screen to the original structure. So select transfer model, yes. Coming to this dialog box, you need to select the values. Actually you can see as per grid it has started here, and this distance is 6 and it is in positive Z direction, so we select +6, select OK, OK, OK. So you can see since this was 6 meters, we selected 6 meters in positive Z direction and the structure got attached to it. Now as per our figure there are columns here, 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 here. Okay, no problem. Once the building is formed, you can apply so here there are nodes and beams which are irregular in number due to deleting few of them, so we need to rearrange them. So we select the entire structure, go to geometry, select renumber, select nodes, select yes. Okay, similarly select renumber, select members, select yes and select accept. So now they are arranged exactly as per our requirements. Once the renumbering is over, you can go to general tab and give the property rectangle property, or else you can give trapezoidal, or else circular, but we select rectangle 0.35 by 0.25. Select the entire structure, assign it to the entire structure. Once this is over, you need to select the entire structure and raise the structure to 7 stories by using translational repeat by going into geometry. Select number of steps 7 and default spacing will be 3. So this got in X direction. Select Ctrl Z, select the entire structure, go to geometry, select translational repeat, select 7 steps, give default spacing as 3 since the height we took is 3 meters and global direction will be Y. Select OK. You can view the top view as it is in our original figure. Now we go to supports, select the finite view, give support as pinned support, select support, select the bottom nodes, assign to the bottom nodes. Then coming to loads and definitions, we select loads and definitions, select load case details, dead load, loading type will be dead, add, close. As per our figure, load is 6 kN per meter square in these 3 and this 3, this 3 and this 3, and 7 kN per meter square in the smaller rectangles and 8 kN per meter square in the bigger one. So select dead load, select add, go to floor loads, select pressure as -6 kN per meter square. Y range will be 3 to 24 meters since the 7th story roof will be at 24 meters height, and X range will be, as you can see, X range will be from here to here, which is 0 to 10.5 meters, and Y range will be 0 to 4.5 meters. Select add, then -6 kN per meter square will be from here to here. So we select Y range will be 3 to 24 meters, X range will be 0 to 11 meters since this length is 11 meters, and Z range will be 6 to 10.5. Select add, and coming to next, it is from here to here. So we select X range from 14 meters to 24.5 meters, and Z range will be 0 to 4.5 meters. Select add. Similarly, the last one will be X range will be 13.5 to 24.5 meters, and Z range will be 6 meters to 10.5 meters. Next, coming to -7 kN per meter square. Y range will be same for all the loads. Coming to X range, it is from 0 to 24.5 meters. X range will be 0 to 10.5 meters, and Z range will be 4.5 meters to 6 meters. Then comes the next from here to here, which is 14 to 24.5 in X range. The range will be similar. Select add, and the last one is -8 kN per meter square. Y range is same. X range is 10.5 to 14 meters. Since it is from here to here, 10.5 meters here, and it will be up to here 14 meters, and Y range will be up to 6 meters. So select 0 to 6 meters, select add, and close the dialog box. Now you can view all the loads being assigned automatically. Once the loads are assigned, then you can go to design tab, select concrete, select the particular IS code, and define few parameters. Compressive strength of concrete will be 30,000 kN per meter square. Select add. Similarly, yield strength of reinforcement will be 415,000 kN per meter square. Same will be for secondary reinforcement, and give the maximum ratio of steel as 3%. define commands, define beam, define column, then take off. Assign this to the entire structure. Similarly, the yield strength of primary reinforcement and secondary reinforcement. Then select design beam and select beams parallel to X direction and beams parallel to Z direction and assign then you select design column and select beams parallel to Y direction and assign to the selected beams. Once the assigning is over, you can go to analysis and print, select add, then go to analyze, run analysis, save the structure. The analysis might take some time depending upon your RAM. Once it is over, you can go to post processing mode and view the deflections. And other requirements. Reactions are obtained by selecting Reactions tab, stretches, graphs, animation. You can see the displacement section, displacement animation. Select reports. You can obtain the reports by going to output and whatever the details you require, send it to the other side. Load cases will be only single load case. Select OK. In this way you can obtain the maximum moments whatever you require in reports. If you need to transfer these reports to MS Word, select File, select Export Report and MS Word file. Select Save. Select Open. The MS Word file opens and printing starts from beginning. You can see it up to the end of the report. It will be doing its work. So this is the end of the session. Thank you.